Arithmetic means very simply, if we have suppose n observations are obtained from a sample from population, and suppose the values are say x1, x2, xn. X1 is the value of the first sample, x2 second, and so on. The arithmetic mean is nothing but the sum of all these observations divided by the total number of observations. The way we calculate mean or average. So mathematically, it is generally represented by x bar. It is x1 plus x2 plus up to xn divided by n, where it is sum of observations by number of observations. We also generally use this Greek symbol called sigma, capital sigma, I running from 1 to n. This Greek symbol sigma basically means nothing but x1 plus x2 plus xn. It is also known as summation. So, but this formula can be used only when you have discrete values. You do not have frequency distributions. Okay. Suppose you have 10 values and all of them are coming only once or say twice, but there is no repetition in that. So when you have these discrete values, you have said 10 temperatures, you have 20 temperatures. And for 10 days, you are recording the temperature, and then you calculate the average and you say that the average temperature of for this 10 days was this much. Or you are recording the temperature for 7 days, for a week, and then you calculate the average and you find out, okay, this average temperature for a week is this. Then you can use this particular phenomenon. But what happens is sometimes we have grouped data. Now, the meaning of grouped data is that we also have certain frequencies in it. For example, what happens is, in case of a data, when we have a larger data set, there are certain figures, there are certain values which will repeat itself, or which we obtain, say, many number of times. So in that cases, what happens is, instead of using this formula, if we use this formula, the calculations will be very large, or it will be huge. So what we can do is we can classify the data set into say different categories or into different groups. So these categories or groups are basically known as the class intervals. And then we will see how many times this particular figure is being repeated. So that is known as the frequency. For example, if we have one value, say x, and x is repeated say 10 number of times, then the frequency corresponding to x will be 10. If y is repeated 20 number of times, then the frequency corresponding to y will be 20. Now, instead of adding x 10 times, what we can do is we can simply multiply x with 10. Okay. So we can simply multiply the values with their frequencies and then calculate the mean. So this is how we calculate the mean for a grouped data. So the formula is given by, again, summation fi xi by summation of fi. What we do is, here we have the total frequency. The total frequency basically means the total number of observations, because we are calculating the repetitions. So if we add up all the repetitions, we'll get the total number of observations. And here we are simply multiplying each observation with their frequency, and then we are summing it over. This we will see later on. Now we have some properties of arithmetic mean. Is for the first property is that the sum of deviation is 0. So if I subtract each observation from its arithmetic mean, and then if I sum it, it comes out to be 0. If this is not happening, then it means that the arithmetic mean calculated is wrong. If the arithmetic mean is calculated in a correct way, then what we can do is, if we subtract each observation from its arithmetic mean, and then if we sum it, it will be 0. Why it happens? Because some of the observations will be less than the arithmetic mean. Some of the observations will be greater than the arithmetic mean. Arithmetic mean is somewhere in the center. So the observations are less than the arithmetic mean. If you sum those, you will have a negative value. And for those observations which are greater than the arithmetic mean, if you sum them, you will have a positive value. And if you add all this, the negative value and the positive value will get cancelled, and the value will be eventually 0. Now this is, again, see, if you are, instead of using this value xi, if you are using a deviation value, say a, and then the arithmetic mean is calculated in this way. Again, for a frequency distribution, again, if you are using a deviation value, it will be calculated in this way. And this formula basically means that arithmetic mean depends both on change of origin as well as change of scale. Meaning, if you have set 10 values and you have calculated the arithmetic mean, now if you add certain values to each of these 10 values, and then you calculate the arithmetic mean, there will be a change in the arithmetic mean. Similarly, if you multiply each of the values with something, and then if you calculate the arithmetic mean, again, there will be a change in the arithmetic mean. So let us see an example. So this is a frequency distribution of weights of sorghum ear heads, given value, and it has been asked to calculate the mean value. Now you see what they have done is, they have formed groups. So it is the weight of ear head of sorghum in grams. So they have formed groups, so 40 to 60 gram, 60 to 80 gram, 80 to 100 gram, 100 to 120, 120 to 140. Similarly, They have formed groups with interval of 20. Now this is the frequency. This is the now 6 represents that there were 6 earheads which had weight in this range 40 to 60. Similarly, there were 28 of them having range between 60 to 80. There were 35 of them having range between 80 to 100 and so on. So you calculate the total frequency 190. Now 190 means the total number of earheads that you opted. 6 earheads belong to this category, 28 belong to this category. So if you add all this, irrespective of the category, in total number of category, we have this much amount of earheads. Okay. Now how to calculate the mean? Here you have an interval. So what we do is we simply calculate the midpoint. How you calculate the midpoint? 40 plus 60 divided by 2. The average of these two. You have to calculate the average of these two. So see, 40 plus 60 is 100, divided by 2 is 50. 60 plus 80 divided by 2, that is 140, it is 70. So you calculate the mid value and then you multiply it with the frequencies. Now we told that it is x bar is nothing but summation of fx, that is this one summation divided by n, or summation of f. So this is 21360 divided by 190, which comes out to be 112.4 gram. That means for this 190 sorghum earhead, you can say the average weight of the earhead was 112.4 grams. Okay. Similarly, there is another example. See the frequency distribution of seed yield of sesamum given in the following. Here also we calculate the mid value. This they have done using a deviation. But instead of using a deviation, now why we do deviation is because it simplifies the calculation. But instead of using a deviation, what you can do is you got the mid value, you simply multiply x with fx. You multiply this column, mid value x, and this column. This is again the mid value of this. So you multiply this column, you will get some total, you divide it by 100 and you will get the value as 154.3 grams. Okay. Now after mean, there is something known as the median. So now generally what happens is the median is generally, it means the middlemost value of a distribution. And generally median is calculated for those data where we do not have a quantitative value, or we generally have a qualitative value. So the median of a set of n measured observations, say x1, x2, xn, is the middle value when the measurements are arranged in an array according to their order of magnitude. So what we need to do is, we know that for a qualitative data, we cannot do mean, because there is no mathematics in it. There is no mathematical value to it. There is no numerical value to it. But what we can do is we can at least order them in an ascending or a descending order. For example, suppose if the variable is color of a flower. So what you can do is you can do deep red, you can do light red, you can do pink, you can do crimson red. So based upon the intensity of that particular color, you can order the variables, right? And then you will get a middlemost value. Now, if n is odd, then the middle value is the median. But if n is even, in that case, what happens is we'll get two middle values and the average of the values is median. For example, if the number of observations is say 7. So 1, 2, 3, 4. If it is 7, so we are ordering it as in an ascending order as 1, 2, 3, 4, 5, 6, 7. Now you see 4 is the middlemost value, because it is what it is doing is it is partitioning the entire series into two equal halves. Before 4, there are 3 values, 1, 2, 3. And after 4 also there are 3 values, 5, 6, 7. So you are getting a observations is even, say 6. So you have 1, 2, 3, 4, 5, 6. Now in that case, what happens is you are not getting a particular median. So what to do? You see, if you take 3 and 4, there are two middle values, 3 and 4. If you take 3 and 4, then there are two values in the first, 1 and 2, and 2 values after that, 5 and 6. Now what you can do is you take these 2, 3 and 4, and you take the average of them. So 3 plus 4 is 7. So 7 divided by 2 is 3.5. So in that case, 3.5 is the middlemost value, or it is the median. So for odd number of variables, we will get a particular median. For even number of variables, you will not get a particular median. What you need to do is you need to take the average of two middlemost values. Okay, so this is, I told you that the median is the value which divides the set of observations into two equal halves, such that 50% observation will lie below the median and 50% observation will lie above the median. So the median is not affected by actual values of the observation, but rather on their positions. Because in median, what we are doing, we were summing the values and then dividing. So the mean was getting affected by the values of the variable, but in median we are just arranging them in an increasing or a decreasing order. So it is not affected by the value of the observation, but they are on their position based on the intensity. Now this is generally for a grouped data, how you can calculate the median. So this is a bit cumbersome formula, lm plus n by 2 minus summation f naught into c. Now this n is the total frequency. This will be clear when we see an example. Total frequency. Fm is the frequency of the class where the median lies. How to calculate that, I'll show you. Lm is the lower class boundary of the class. This is the sum of frequencies below the cumulative frequency, and this is the median class interval. But before we go to the formula of this one, grouped frequency, let us see an example of it where it is ungrouped. So suppose the weight of sorghum earheads are this: 45, 60, 48, 100 and 65 grams. Now what we need to do is, first we need to arrange it in an ascending order. So the arrangement will be 48, then 40, 45, then 40. So this is the arrangement in an, okay. So you see, this is the arrangement in an ascending order, right? Now you see, in this case, what happens is there are how many items? 1, 2, 3, 4, 5. There are 5 items. So what is the middlemost value? The middlemost value is this 60. Because since n is equals to 5, so n is equals to odd in this case. So if we consider 60, so here we have 2 observations. And again, here we have 2 observations. So 60 is basically the middlemost value. So here 60 is the median of this particular distribution. So it is 60. But let us see another example. Now you have 45, 48, 60, 65, 65 and 100. Now 65 is coming twice, but the number of observations have gone on to 6. So in this case, your n value is 6. Now what happens for 6 is again an even number. It is not an odd number, right? So you cannot find a middlemost value for that. So what you do is 1, 2, 3, 4. Now you see, if you take 60 and 65, if you take this two, then what happens is here you have 2 observations which are greater. Here you have 2 observations which are lesser. So how to find out the median? The median will be nothing but the average of these two. Okay. Okay. Now you see the frequency distribution of weights of sorghum earheads. So now again, the previous example for calculation of mean. So here you see what we have done is we have simply classified the data into groups: 40, 60, 60, 80, 80, 100, 100, 120, 120, 140, 140, 160, 160, 180, and 180, 200. And these are the number of earheads. So there are 6 earheads which belongs to this category. There are 28 belonging to this. There are 35 belonging to this, 55 belonging to this, and so on and so forth. What we need to do is now we calculate these are the lower limits. Okay. Sorry, the upper limits. Now you see, less than 60 we have this much, less than 80 we have this much, less than 100 we have this much. And what we do is, next step is to calculate the cumulative frequency. So what is the cumulative frequency? We simply add. You see, the first cumulative frequency is 6. Next, what we do is we'll add this 6 with 28 and the value is 34. Next, what we do is we add 34 with 35 and we get this value as 69. Next, what we do is we add 69 with 55 and the value that we get, these are the cumulative frequency. Now I have to find out what is my n. So my n was 190, the total frequency, and the cumulative frequencies are obtained by adding each of them. One check measure you have to find that the final cumulative frequency and this value will be same, because cumulative frequency is obtained by adding each of the values and this is the total frequency. So this two has to be same. So what we need to do is we need to determine what is our n. So in this case, our n is 190 and we then find out the divisor of n by 2. So n by 2 is 95. Okay. Now we will find out the cumulative frequency where this n95 lies. We see here we have a cumulative frequency of 69. Here we have a cumulative frequency of 124. So 95 lies somewhere in this range, in between these two. Okay, in between this class and in between this class. It is somewhere where this particular value of 95 lies. Okay, so so what we do is we need to find out that particular cumulative distribution which is just greater than 95. So here it is 124. Then this particular class is known as the median class. Okay. There we were getting directly median, but since here we have a class interval or we have a group interval, we will get the median class. Suppose this is MC. Okay. Now, and the lower limit of the median class is 100. So the cumulative frequency up to 100 is 69. So, and the frequency of the median class is 50. Now, if we plug in the values in this one, you see, this was 100, this was 95. This is the cumulative frequency previous than is 69. This is the frequency of that class, and this is the class interval. You see, here we have obtained. This is the lower limit 100 of that particular class. This one. Okay. Then 95 is the value of n by 2. It comes over here. 69 is the value of summation f0. That is the value of the cumulative frequency, which is previous to the median class. That is 69. It comes over here. Then we have frequency of the median class. This one, it comes over here. And then we have the class interval. That is 120 minus 100 is 20. If you add all these values, this is the value of median that you will get. What you need to understand for this particular distribution is that you need to know this particular formula. You need to know this particular formula, and you have to understand like what is the lower limit, what is the median class, and what is the this thing. If these things are clear to you, then you can calculate the median easily. But this is the theory behind median calculation. Obviously, nowadays softwares had made our life much more easier. In software, you put the data, you simply write one line code and you will get the median. So this has improved our life, but this is the theory behind median calculation and how median is obtained. Okay. Next, we have something known as the mode. So we saw mean, we saw median. Now it's something known as the mode. So what is basically the mode? So the mode is the observation which occurs most frequently in a data set. So the frequency of the data set or the data value that has got a maximum frequency is generally known as a mode. So particularly for a group data set, what happens is the mode is calculated using this formula. So L is the lower limit of the modal class. Fs is the frequency of the class succeeding the modal class after the modal class. Fp is the frequency of the class preceding the modal class, and C is the width of the class interval. Now in case of mode, what we need to do is we need not find out the cumulative distribution. For median, what we were doing when we were finding out the cumulative distribution. Like in mode ke liye ye zarurat nahi. Cumulative distribution, there is no need to find out. So for example, in case of continuous distribution, symmetrical distribution, what happens is this mean, median, mode will be coinciding. If the distribution is symmetrical, distribution symmetrical means the data will follow a normal distribution, or will get a somewhat this kind of a graph for a symmetrical distribution. So if suppose you have a symmetrical distribution where you have this kind of graph, then what happens is the mean, median, mode will be coinciding at a certain point, say this one. But if the distribution is not symmetrical and it is slightly skewed, then this particular relationship between mean, median, mode holds. That is mean minus mode is thrice of the mean minus median. So with this formula also, suppose you know the mean and you know the median, then you can find out the mode. Or if you know any two, mean or mode, you can find out the median. Okay, see now this is an example. Acha. Now what happens is if the data is suppose discrete data, you do not have a you do not have a group data, you do not have frequency. Then just by looking at the data, at the particular data that is coming maximum number of times and having maximum frequency, you can say that this is particular the mode of the distribution. But in case you do not, in case you have a grouped frequency distribution, so in that case, what happens is you have to use this formula. See, this is an example, the yield of paddy from different fields in tons per hectare. Now here what happens is the modal value is 6. Now how did I say? You see 6 is coming maximum number of times. Here 1, 2, 3, 4 and 5. So generally mode is that particular value which has the maximum frequency, meaning which is repeated the maximum number of times. Now here we can see that this value 6 is coming 5 number of times. Are there any other repetition? You see, no, there are no other repetitions. So thus we can say directly that modal value is 6 tons per hectare. But now suppose you have a grouped frequency distribution. Again, the same example of the year heads of sorghum. Okay. Now we will see the modal class is that particular class that has got the maximum frequency. So here you see out of this, the maximum frequency is 55. Okay. Then this particular class 100 to 120, is the modal class. This particular class is the modal class. Okay. Now, if we use the formula was this L plus. So the formula first thing we have is L. So L is the lower limit of the modal class, that is 100. For us, it is 100. Okay. Then you have FP and FS and C. FP is the frequency of the preceding class. So preceding class for the modal class is this one. The frequency is 28. And FS is the frequency of the class succeeding the modal class. So this is the modal class. The succeeding frequency is 15. And then you have C. C is the width of the modal class, which is 120 minus 100 is 20. So if you plug in all these values over here, then you will get the mode up to be 109.23 grams. So this is how you calculate the mode for distribution which has got frequencies or continuous distribution. Okay, now there is something known as the geometric mean. Okay, now as we saw the arithmetic mean, so there is also something known as the geometric mean. Although geometric mean is a bit difficult to understand mathematically, and there are also certain limitations of geometric mean, but there are certain situations where we cannot use an arithmetic mean and we have to represent it using a geometric mean. So geometric mean of a set of observation is given in terms of logarithms. Okay, so what we need to do is, so if GM, the geometric mean, we have say n observations, is nothing but the nth root of the product of all these, x1 into x2 into xn. So if I take, this is from the basic principles of logarithm, that if I take log over here, so this 1 8 comes outside and then we take the summation. So just let me give you an example instead of going into much more mathematics of geometric mean. So suppose there are 4 items, 2, 4, 8, 16. So how to calculate the geometric mean? What we need to do is we need to convert them into their logarithmic value. Okay. So 2, 4, 8 and 16. Then we have taken log 2, which is this, log 4, log 8 and log 16. And then you find out the total of this. So you got 3.0103. And then if you divide this by n, that is by 4, then you get, this is the mean. But this is what? This is log g. This value is equals to this value. This is not the geometric mean value. This is the log of geometric mean value, right? So what you need to do is, then you need to find out the anti-log for this value, and the geometric mean you will get is 5.66. If the log of this is, if this is log this much, the anti-log value is this. Similarly, for a group frequency distribution also you can find out. Harmonic mean is nothing but the reciprocal. In arithmetic mean, we were simply adding x1 plus x2 plus x3. In harmonic mean, we will add 1 by x1 plus 1 by x2 plus 1 by x3 in this way. Suppose, let me give an example. There are 5 agricultural laborers and they can complete weeding operations on 100 square meter land in this many hours. If these 5 laborers are employed for weeding in 500 square meter area, how many hours will they complete the work? For this kind of problem, you cannot do a arithmetic mean. You have to do an harmonic mean, because you have to find out that in 1 hour, how many square meter of area they can cultivate. So for the harmonic mean, what we do is, see, this is the formula. So this n will go up. So this is 5 because there are 5 laborers, and you have to find out 1 by 4, 1 by 5, 1 by 5 and 1 by 6, because they can do in 4 hours, right? So for how many in 1 hour? So 1 by 4, in 1 by 5, 1 by 6 in this way, and this will be 5.21 hours. So for this particular kind of an example, you have to go for a harmonic mean, and this is how you calculate the harmonic mean. Now there is also something known as the weighted mean. Now weighted mean in fact is more statistically sound, and generally what happens is this is used more as compared to arithmetic mean. Weighted mean means we are giving certain weights. Weights can be used to show the importance of that particular value. Okay, so in the we are using the weights. For example, the average yield of IR20 paddy from 2 localities are 55 quintals and 65 quintals. Now you see, this 55 quintals has come from 20 hectares of land, and this 65 quintals have come from 10 hectares of land. Now there is a difference, right? I cannot simply add both and say, okay, this is the average. What we need to do in this case is we need to consider the size also, or the size of the land from which this average yield is coming, because then only we can justify our statement. Okay, so instead of taking simple average is 60 quintals per hectare, this is not correct. So what we need to do is we will simply add certain weight to it. So it is 55 into 20, 60 into 20 plus 20 plus 30. So this is what we are getting is 58.3 quintals per hectare. The difference between this is here we are not considering the size of the land, but here also we are considering the size of the land from which the yield has come. So this is known as weighted average, and particularly for realistic sense, this weighted average is much more valid and it is much more used as compared to simple average. Generally what happens is these weights can be anything. These weights can be the size of the land. It can be something else also. These weights basically shows the importance of certain additional features. Okay. Generally, these are the relationship between the three means. For any data set, the arithmetic mean is always greater than the geometric mean. It's always greater than the harmonic mean. Now, okay, so these are some of the properties of an arithmetic mean, good of a central tendency, that it has to take all items into consideration. It should not be affected by extreme values. It should not value from sample to sample, and it should be capable of further statistical analysis. Now, this thing is very important. One thing comes to our mind always is like when to use different averages. When should I use an arithmetic mean? When should I use a geometric mean? When should I use a harmonic mean? Okay. So basically it depends upon the nature of the data and the nature of frequency distribution. As I told you that if the data is qualitative one, then only mode can be computed or median can be computed. When we are interested in knowing, say, the soil type in a locality or typical cropping pattern in a region, we can use the mode, because we need to find out which cropping pattern is more predominant in that particular region. We need to find out that which particular soil type is more predominant in a particular region, whether it is a sandy soil or it is a loamy soil or it is a clayey soil, which is more predominant. So in those situations, we need to find out the mode. If the mode shows that suppose the soil is loamy soil, that it basically means that in particular region, loamy soil is more predominant as compared to other soil. On the other hand, if the data is a quantitative one, then we can use any one of the average. We can use arithmetic mean, or we can use median, or even mode also. Okay. Again, we have to consider whether the data is skewed or not. If the distribution is skewed, then the median or mode will be a proper average. In case of suppose there are raw data with extreme values, either small or large, the median or mode is the proper average. In case of a symmetrical distribution, we can use any one, because we know for symmetric distribution, all three will be equal. Mean will be equal to median, will be equal to mode. And when we are dealing with objects like rates of certain commodity, speed, prices, we generally use harmonic mean, as I have shown you the case of agricultural laborers. If we are interested in labor relative change, for example, in case of bacterial growth, cell division, there we go for geometric mean, because generally we go for logarithmic series. We have to see how much bacterial growth is there since yesterday, or how many cells have divided since yesterday. Then we go for geometric distributions geometric mean in those cases. Now, after central tendency, we know measure of dispersion. So once we have done with central tendency, we need to know what is the variability in the data, or how much variability is present in the data, and how to find out that is obtained through measures of dispersion. Generally, what happens is, if the variability in the data is more, okay, if the variability in the data is more, we say that the data is bad. If the variability in the data is less, we say that the data is good. But there has to be a measure which will account for this variability. Simply by looking at the data, I cannot say, okay, the variability is more or the variability is less. So there has to be certain measures. These particular measures, which will look for the accountability, or that will account for the variability present in the data, are known as the measures of dispersion. So suppose now we have distribution of yields of 2 paddies from 5 plots. So there are 2 varieties, and you see these are the from 5 plots we are getting the yields. Now it can be seen for both of the variety, the mean yield is 42 kilograms for both of the variety. But we cannot say that the performance of 2 varieties is same, because you see, for the first variety, there is a greater uniformity in the value. So the value is 45, 42, 41, 40, somewhere in the same. But for the second variety, you see, you have also got yields such as 30, and you have also got yields such as 54. So there is a huge discrepancy or a huge variability for the second variety. Even though the mean is same, the average yield is same, but there is dispersion, or there is variability in the data. So this variability is accounted by certain measures, which is called the measure of dispersion. Okay. Now there are some measures of dispersion. One is the range. Range is nothing but simply the maximum minus minimum. Okay. Suppose the kapas yields kg per plot of a cotton varies from 5 plots at this. So the range is the maximum minus minimum. So the maximum value is 11. The minimum value is 8. So it is 3 kilograms. So this is the range. It is a very crude measure of dispersion, or the crudest measure of dispersion. What we do is we simply take the maximum value and the minimum value and we subtract and we say that this is the range of the data. Okay. Since it takes only the maximum and minimum values into account, it is very unstable or an unreliable indicator. And it is not, it is affected by extreme values. For example, if we have 15 instead of 11, immediately the range will change. From 3, it will line up to 7. Okay. So this is one of the reasons that range is used, but it is used seldom. Then we have quartile deviation. So quartile deviation is nothing but this formula. We find out the third quartile and we find out the first quartile, and the difference of that we divide it by 2. So these are the paddy yields from 14 plots. We need to find out, suppose the third quartile obtained is this one, 55.75, and this is the first quartile obtained. And if you subtract the difference, then this is the quartile deviation. So these are some of the measures that account for the variability of the data. If the range is more, that means there is more variation in the data. If the quartile deviation is more, that means there is more deviation in the data. If it is less, it means that there is less deviation in the data. But these measures are also not very good measures. Then we have something known as the mean deviation. In mean deviation, what we do is we subtract each value from its arithmetic mean, and then what we do is we take the modulus value. Taking the modulus value means we are ignoring the sign of the variable and we're just considering it to be positive. Be it positive or negative, we just consider it to be positive, and then we divide it with total number of observations. Now here, one of the disadvantages is that since we are taking the absolute value or we are taking the modulus, what we are doing is we are just ignoring the signs. So we do not know which is positive and which is negative. Okay, we are ignoring the signs. So this is one of the disadvantages of mean deviation. So this is one example. So you see kapas yield is given in kg per plot of a cotton variety from 7 plots. So what we need to do is first we calculate the mean. The mean is 7, and then we are subtracting each value from 7. Say 5 minus 7 and taken as the modulus. So 5 minus 7 comes out to be minus 2, but we will take only 2. So 2, 1, 0, 0, 0, again 1, 2. So this comes out to be 6. So 6 by 7, this is the mean deviation. Similarly, for a grouped frequency distribution also, again, we can do it in that way. We'll find out the middlemost value. We'll subtract each value from X bar. Then we'll multiply frequency with it. And then we divide it with this much, total number of total frequency. So total frequency is 100. So this is the mean value that mean deviation that we get. So mean deviation advantage is that it is fairly stable. It ignores the sign of deviation. It is not possible to use for further statistical analysis. This is the disadvantage that I told you, that you will not be able to know which is smaller and which is greater because we are ignoring the sign. So all of this is overcome by something which is known as standard deviation. So in standard deviation, what happens is we ignore the sign of deviation. We may square the deviation to take a negative value as positive. After calculating the average square deviation, it can be measured expressed in original units by taking its square root. So this type of deviation is known as standard deviation. So what we are doing is that variation, that formula for mean deviation and standard deviation is same almost, but instead of using a modulus value, here we are using a square term, and then we are taking the square root of this. If I don't take the square root of this, this is known as the variance. But since I'm taking the square root, it is known as a standard deviation, and this is the best measure of dispersion that we have, and it is the one that is generally used as compared to other measures of dispersion. And for a group, what we have is we'll simply have an F over here for a group frequency distribution. So we have a frequency over here, and we are taking again a frequency over here, and this is the formula. Generally, the standard deviation is considered to be the best. Okay, so this is the basics of exploratory data analysis about the different measures of central tendency and dispersion that we have. Now we'll quickly, due to paucity of time, we'll quickly move into certain inferential statistics, where we'll talk about the test statistics. So let me just quickly move on to descriptive inferential statistics. Okay. Now we have something called a statistical hypothesis. So generally, what is a type of statistical hypothesis? Is a statistical hypothesis is an assertion, or it is a statement that we have in our experiment about a population parameter. Whenever we do a certain experiment, we will have an objective or we will have an hypothesis. Suppose if we are doing an experiment with 2 fertilizers, we will like to say that the new fertilizer has a better performance than the older fertilizer, right? So this kind of an assertion, or this is known as a hypothesis or a statistical hypothesis. And this hypothesis has to be tested. If this hypothesis comes out to be true, then we will say, okay, our new fertilizer is performing better. If it is not coming out true, we'll say that it is not performing better. So for example, in engineer may be interested in comparing the strength, the mean of a population to be specified well. Okay. So this is okay. Burning rate is a random variable. This things can be skipped. Now, generally a statistical hypothesis is represented in this way. Say H naught, that is the null hypothesis or the hypothesis of no difference. The first hypothesis that we have in our mind is called the null hypothesis. I say, suppose the mean yield or the mean of something is 50 centimeter per second. So this is the null hypothesis that I have. Contrary to this, what I can have is I can have one hypothesis which is not equal to, meaning it can be greater than or it can be less than. So this kind of an hypothesis is known as a two-sided hypothesis. Or I can say it can be less than 50 centimeter per second, or it can be greater than 50 centimeter per second. So these are one-sided hypotheses where we are considering only less than or we are considering only greater than. And this H1 is known as an alternative hypothesis. So the hypothesis that counteracts the null hypothesis is the alternative hypothesis. So a procedure leading to a decision about a particular hypothesis is called test of hypothesis. Generally for hypothesis, what we do is we'll take a sample from the population, we'll perform the experiment, we will do certain tests, and then we will see if the results conform to that test or not. So if this information is consistent with the hypothesis, we'll say that the hypothesis is true. If it is inconsistent, we'll say that the hypothesis is false. So see what happens is, this is the thing. Now, based on this, what happens is we will divide the sample range into 3 criteria. Okay, if I say that the mean is 50. So if the test comes over here, I'll say, okay, my hypothesis is correct. So we fail to reject H0. But if it comes in this way, or if it comes in either of the way, what we do is we'll reject the H0. So these particular regions are known as the critical region. So if our test statistics falls in the critical region, what we do is we'll reject the null hypothesis. And this is known as the critical region, and this is known as the region of acceptance. This is the region of acceptance. Now what happens is, generally when we have this kind of an hypothesis not equal to, so this is a two-tailed hypothesis where we have, it can be greater than also, it can be less than also. So we will have 2 critical regions. But when we have a greater than or a less than 1, then in that case we'll have only one particular critical region. So now there are 2 kinds of errors in statistical hypothesis theory. If rejecting the null hypothesis H0 when it is true is called as type 1 error. So when the null hypothesis is true, but still we are rejecting it, it is an error. So this type of error is called a type 1 error. It is also known as level of significance. It is generally denoted by alpha. And generally for agricultural experiments, the level of significance is kept out to be 5% or 0.05. Meaning that in 100 cases, there are 5 cases where we can go wrong. Generally for medical experiments, it is 1 cases, because even problem with 1 patient is a huge thing. So there the level of significance is 1%. But for agricultural experiments, generally the level of significance is 5%. Similarly, failing to reject the null hypothesis which is false is called type 2 error. If the null hypothesis is false, but still I am accepting it, then it is called a type 2 error. And this is generally represented by beta. Okay. Now you see, this is the decision rule. Null hypothesis H0 is true and you are accepting it, means no error. H0 is true and you are rejecting it, means type 1 error. H0 is false and you are not rejecting it, sorry, accepting it is not error, no error. And H0 is false and again you are accepting it is type 2 error or beta. So alpha is the probability of committing type 1 error. This I told you. It is also known as a level of significance, the alpha error or the size of the test. Okay, so as I showed that this is the critical region. In both sides, you have a critical region. This is for h naught mu equal to 50 and not versus mu not equal to. So you have two critical regions, one over here and one over here. So if your test statistics falls over here or over here, then you will say that your test is non-significant. Otherwise, here if you say it is, you will accept the null hypothesis. So similarly for beta, now instead of going into more details, I'll show some of the tests now. More theory and how you can do those tests. Okay. So this thing has already been told. Generally, what we do is we have certain tests, like we have a t test, we have an f test, and we have a chi-square test. And generally, if the value of t test is greater than the value of t, we will reject the null hypothesis. Similarly for f, for chi-square. And there is certain thing called known as the p-value. The p-value is nothing but the probability value attached to the value of test statistic. So see, these are the procedures in we set up our probabilities and null hypothesis. This I have already told, type 1 error, type 2 error. Now this is the chart that basically shows you what are the different tests that you can perform and under different conditions. So you have to see how many groups you have, 2 groups or more than equal to 3 groups. For 2 groups, unpaired test, parametric test, you have a t test. Non-parametric test, you have Mann-Whitney U test. For paired test, again you have a paired t test. For non-parametric, you have a Wilcoxon-Steinman test. If the number of groups is more than 2, 3 or greater than 3, then again you have paired as well as unpaired. For paired, you have one-way ANOVA. If you want to do a non-parametric version of it, you have to do for Kruskal-Wallis test. Again, for paired, for parametric test, you have one-way repeated measure ANOVA or two-way ANOVA. And for non-parametric, you have Friedman test. Okay. So this is a flow chart which shows that which test you have to perform under what situation and what kind of data you have. Okay. Now we perform the basic first 2 sample t test, which is the unpaired t test. So the assumption in this case is that the 2 samples must be independent or unrelated, and there has to be a normality. And then both of the samples or groups must have equal variances. This is an example. You see comparison of mean body weight of the time of mating in one group of EVs, which has been flushed, and another group which has not been. So each EV in a random sample of 54 EVs is randomly allocated to flushed or control group. So there are 2 groups, control groups and flushed, and we are taking the weight. Now what you do is, okay. So the null hypothesis in this case is that the mean body weight in the population are equal, and alternative hypothesis is that they are different. So you perform this difference in mean by standard error, this test you perform, and after the group statistics, you get this Leibniz test shows equality of variance, and this is something that you get. Now you see the first line of t test. This has been done using software, using our software. So first line of t test that you shows, it is showing equal variance has been assumed, is relevant, and you see that the 2 variances are not significantly different in this case, the degrees of freedom. So what you need to do is you need to check the value, the p value. Okay, so if the p value is less for softwares, if it is less than 0.05, then you can say that your test is significant. If it is not less than 0.05, it means that it is not significant. So see here in both of the cases, the p values are 0.018. Okay, plus minus standard error, plus minus standard mean error for mean. Now you see, since it is not less than 0.08, thus we can say that the null hypothesis is not rejected, it is accepted. That is, there is no significant difference between flushed and the control group. Okay. These are the thing. This is not required. Graphically, you can also represent it with the help of bar diagram and also the help of boxed plots. Here, this is the control group and this is the flushed group. Although you see here, you can see a significant difference in bar plot, but statistically they are not different, because statistically when you do the t-test, we saw that it is the p-value is not satisfying. Okay, this is not required. Again, we have something known as paired t-test. Generally, paired t-test is performed in situation where the population is same. Okay, for the same population, suppose same participants. First, you have given certain medicine. You're checking the observation before giving the medicine, and you're doing it after giving the medicine. So the population remains the same at different time points, 1 and 2. In those situations, we can generally do the paired T test. Okay. In those cases, we generally use the paired T test. Therefore, it is also known as a before-after test. So there is a test statistic for this. Generally, everything can be done in software nowadays. Okay, now there are also certain methods of pairing. Generally, we'll go for the assumptions. It has to be paired. We take difference between the observation in each pair and set up difference of the point is approximately has to be normally distributed. So this is one example where independent diabetic dogs were given 11 and there is a low fiber diet and there is a high fiber diet. So for each of these 11 dogs, what they have done is they have given 2 diets and then they have measured the serum glucose levels with insulin independent diabetes mellitus. First, they've given a low fiber diet and then they have measured this. Then they've given a high fiber diet and then they are measured. So you see here what happens is the subjects are same, or the values are same, only they are giving different diets. And then they are checking. So in these kind of situations, you can perform a before after test or a paired T test. If there are more than 2 means, generally, then what we do is we have to go for analysis of variance, that is ANOVA. So this is also one test statistic. Here we generally have the F test. So we can access the contribution of different factors by using ANOVA. For example, we have 4 groups. So for 4 groups, what happens is if we do say 2 for each, then we have to do 6 possible T tests. So instead of doing that for 4 groups, we can consider one particular test, that is the analysis of variance. So analysis of variance also, the total variability, it can be done in 2 ways, between treatments, within treatments, for factor A, factor B, and for interaction effects. Now, these are some of the features. For one-way ANOVA is basically the extension of 2 sample test to more than 2 groups. Then there is something called one-way repeated measures. We're not going into the details, theory as well as analysis of how to do this because there's scarcity of time. So we are just knowing on what situation, what you have to do. So one-way repeated measure, extension of PRT test, for example, in the data longitudinal and at different time points. Then you also have 2-way ANOVA. Suppose you have for randomized block design. In those cases, we go for 2-way ANOVA. There are also complex like hierarchical nested ANOVA, lattice inference, split plot. So these are examples of one-way ANOVA. You see there are 2 diets and there is control. For one-way repeated, what we are doing is dose 1, dose 2, we are repeating the experiments. Here you can see this is more, this is less, but here equal number of times. And for 2-way, again, we have 2 feeds. And again, within the feeds, you have variations like 1 portion, 2 portion, and 3 portions. This is one such example. Okay, this is not good. So these are some of the ways where we can do the testing. This is the basics about testing of hypothesis. So with this, we come to an end of our discussion on this exploratory data analysis and test of hypothesis. Now, let me see some of the questions. You can ask questions if you want, and I think in Q&A also there are some questions. Let me see. Acha. Please tell us about the significant p-value. What happens is generally, let me stop share my screen and then let me see the Q&A. Okay. So what happens is whenever we have the basic theory of statistics, testing of hypothesis, what we do is we calculate the test statistic. Suppose we calculate the T statistic or the F statistic. And then for this T statistic and F statistic also, what we have is we will have a table value on a certain degrees of freedom. Now, whenever we find that the value of the test statistic is greater than the table value for that particular degrees of freedom, theoretically, then we reject the null hypothesis. Okay, we say that our test is significant and the null hypothesis is rejected. This is the statistical theory behind it, because whenever it is greater, it means it is falling into the critical region. But in case of software, what we do is whenever we calculate that, we get the p-value. So the p-value is the probability value. In general, if the p-value is less than 0.05, we consider it to be a significant. If it is more, we call it is not significant. in softwares. Okay, one more questions what you have. Sir, please share the PPT possible. Okay, the PPT will be shared. I will share with the coordinators and then you can obtain it from them. Sir, in agriculture also, we will find 1% level of significance. Actually, what happens is generally in agricultural experiments, we generally go for a 5% level of significance, because for 1% level of significance, what happens is it becomes much more strict. Sometimes what happens is your experiment might be significant for 5% level of significance. If it is in the other way, it may not be true. Like if it is significant in 1%, it will always be in 5%. But if it is significant in 5%, it may not be significant in 1%. अब मेडिकल एक्सपेरिमेंट्स में क्या होता है, बिकॉज वी आर डीलिंग विद ह्यूमंस, वी आर डीलिंग विद ह्यूमन ट्रायल्स, सो वन ह्यूमन इज आल्सो मोर प्रीशियस, so we have to go for 1%, we have to consider each humans. But for agriculture, we are dealing with plants, so it is not that crucial, so generally we keep 5% level of significance. Okay, again the same thing, we provide PPT that can be obtained, that I'll provide. Okay,
so thank you very much, Dr. Rahul. First of all, some question is there in Q&A. One question is, please tell us about significant p-value.
Yes, ma'am, that I have answered now.
Yeah, now you have answered that. What level of significance should be taken in animals?
In animals also, ma'am, generally we take 5% level of significance, but if it is on feeding trials and on medical trials, then 1% significant can also be taken, depending on the cruciality of the thing.
Then some questions are there in chat box also.
Yes.
Somebody is asking, in case of social sciences, what should be the significance?
Social science also 5%. In some cases, we go till 10% also, but generally 5% social science experiment.
So basically, general rule is depending upon the problem in hand, yes, how much you can afford to be correct.
Yes, ma'am.
So, for example, COVID detection is something different. Treatment,
they have to go 1%. Yes, ma'am.
Yeah. So cancer detection, I mean, it all depends on different things.
Different problems.
So I think there is no more. One more question is there. What is the difference between RE and adjusted R2, adjusted R square? Basically, R square and adjusted R square.
Okay, actually, ma'am, we have not covered that part.
That is beyond the scope. I think you can ask this question when regression is there.
When regression is taught that time.
Yes, we do have session on that. So basically, this session is mainly just to refresh yourself, because otherwise, you know, even basic statistics we don't cover in 1 hour, but just to refresh various concepts. So, so that you gear up for the advanced sessions, like which will be coming in the subsequent time. If you do not remember any of these things, just go through your textbooks, which you already have. And in case still you have some more questions, Mr. Rahul Banerjee, like we can always post the questions to him. You can give your email address also to them.
Yes,
and
I'll type it in the chat box.
Yes, and we will be sharing this recording also to you, so that like you can see whatever has been covered. You can refresh the things again. So I think with these things, I would like to thank Mr. Rahul for teaching the basic concepts so nicely, refreshing them the things. So it will be surely helpful to them in understanding the subsequent things which we are having. So thank you very much, Dr. Rahul. And in fact, I would like somebody from the participants also to propose a vote of thanks. So I will invite Dr. Parveen Kumar. Are you there? Dr. Parveen Kumar, to thank the... Actually, it is such a big group. It is...
Yes,
yeah. So, okay, thank you, Rahul. Thank you,
ma'am. Thank you, ma'am, for considering me.
Okay, thank you. We'll be back to you in case they require some more help. We'll fix up some other session if needed.
Thank you, ma'am.
Thank you.
Sure. Okay.
Thank you. So now we have our next speaker, Dr. Sant Kumar ji, with us. He is very senior faculty from our institute, National Institute of Agriculture Economics and Policy Research. So he is working on agriculture R&D and did lot of work in this. He is a principal scientist here. So I would like to invite now Dr. Sant Kumar Pandey for his lecture on agriculture research and development system and what is the impact of technology in India, which is very sought after topic by the ICR, because from government, everyone would like to know what is the impact of agriculture research which is being done in our system. So he is covering that issue. So Dr. Sant Kumar. You can unmute yourself.
Thank you, Dr. Jain.
Thank you.
For giving
Please carry on.
this
We
opportunity.
can wait for 2-3 minutes if you want to adjust your things.
So what you told?
We can wait for 2-3 minutes if you want to adjust your.
No, I'm ready. It all depends on you.
Okay. So you can continue. The floor is yours.
Okay, thank you. Thank you very much. Dear participants, I'll be interacting with you for about an hour or so on the topic given to me on the agriculture research and development system and the impact of agricultural technology, how the agriculture research system has developed over years, and what has been the impact of agricultural technology which has been developed by our agriculture research systems. So my appeal would be to all the participants that wherever you feel any difficulty, you just note down and you interact at the end. The beauty of this lecture would be that you will be able to get some kind of indicators, some kind of the methods, so that you can also apply these tools and techniques, indicators for the assessment of agricultural technologies in your area, in your dimension, in your kind of a locality. So to let the tone set before dealing the issue, so the agriculture is the basis of our economy even after 75 years of our independence. 75th year of our dependence, which is, and this agriculture is still relevant for the Indian condition, and if it fail in the development of agriculture, doesn't matter what else we have achieved. It was told by our former Prime Minister of India, Pandit Jawaharlal Nehru ji, and his statement is still relevant in the Indian condition. In the early 50s, when our food grain production was about 50 ton, and the population was increasing at a very fast rate and alarming rate, the Western countries had predicted that the India would starve by the year 1970. But There, the production was proved to be wrong by our scientists, our administrator, and farmers. And contrary to that, our post-independence period witnessed an era of self-sufficiency in food production. So as the planning era began in 1951, the agriculture was given the utmost priority for the development. And the major task to ensure the food security for the growing population, agriculture R&D was directed to attain this task. So agriculture R&D was given this responsibility to ensure the food security for our people. So the country achieved the food security. Despite massive efforts, the country is still confronted with socioeconomic problems like rural poverty, unemployment. Though we achieved the food security, food self-sufficiency, but the social problem is still remain an issue. So since 1951, there has been several fold increase in the production of different crops. Wheat, maize, and the cotton increased more than 5 times. Food grain, rice, the potato, onion have increased more than 4 times. Similar such achievements we have made in case of milk, the poultry, and fish production. About the food front, on the food front, the country has received the international attention and appreciation. Rockefeller Foundation, in its special report, quoted the speed with which Indian farmers and scientists, with the use of some material and the idea from the outside, gave their country an approach to abundant food supply, which has not been duplicated anywhere in the world, including the United States. So this is a big appreciation for the Indian agriculture, Indian farmers, Indian scientists, particularly. So if we see the food production, the front, our the food grain production is about 308 million ton. Of that, we produce rice of about 122 million ton, wheat 109 million ton. We produce about 400 million ton of sugarcane, 330 million ton of horticultural produce. Of that, 103 million ton of fruits and 197 million ton of vegetables. We produce, we are the largest producer of milk, and 203 million ton. Like the other eggs, meat, and fish, we produce the substantive quantity. But because of the high population dependence on agriculture and the low growth, rural-urban disparity is increasing in this country. Though during the pandemic, the period, agriculture did well other than the other sectors of the economy. The last year growth was 3.9%. Of that, the previous year was 3.2%. So this new slide need to be understood at the two level. One level at the forcing environment to the triangle of the policy, institution, and the technology. That the climate is changing, market is changing, macroeconomic environment is changing. In all these prescriptive agriculture R&D role will be totally different for driving the the growth. So with the tone set, the presentation of this would be I'll be dealing with the evolution of agriculture R&D system, how the system has been evolved, what has been the organization development, how the private R&D given the importance, what has been the emerging issues after their development, and the importance of agricultural technology, and some kind of economic assessment of those important agricultural technologies. So the agriculture growth, as we all know, that the agriculture growth is essential for the sustainable economic growth and the poverty reduction for the in the economy. Agriculture not only ensures the food security of the country, but also keep the food inflation under the control and provides livelihood to the millions of rural poor. So realizing this importance, the government has been investing large amount to improve the productive capacity of agriculture by creating necessary infrastructure. For example, for the development of irrigation facilities, R&D, and the rural infrastructure, government has been investing large amount every year. So the agriculture R&D system is in this country is more than a century old. It started with strengthening of agriculture department so at the center and the state governments, and subsequently establishing of agricultural colleges in 1905, and ICR was established in 1929. Since then, agricultural research system has evolved in a well coordinated manner and the responsive system under the domain of ICAR. A large number of the policy and institutional development supported this development, and the significant among these initiatives have been the public funding. So the public funding was the crux for the development of agriculture R&D system in India, for the creation of the infrastructure, for the creation of the scientific manpower, human resource development, so on. So these infrastructure, along with the policy reforms, have strengthened the farm support services, distribution of the quality inputs, and development of the product markets. So there has been a renewed priority for the public investment in agriculture, promoting the sustainable use of land, water, energy, and institutional reforms. So higher public investment in agriculture for irrigation, R&D institutions, and infrastructure is emphasized all level of the government, be it central government, be it state government. So incentives for the business environment in agriculture R&D is also enhanced with the emergence of the intellectual property rights in the field of agricultural science. So the basic principle of the agriculture R&D policy has been the public funding and the provision of R&D services. The public funding for agriculture R&D has grown an upward trend, and the growth has been about 6% during the 90s, during the 2000 decades, marked a shift in the funding of the union and state governments during 60s and 70s. During 60s and 70s, growth in the state funding was significant, because that time we were establishing the state agriculture universities, but since early 90s the central funding outpaced the state funding, and the part of this transfer to the SAU through the programs and the development grants. So the agriculture extension system is mainly under the domain of the state governments, and the central support is available through the development of RKBY, extension reforms, and the technology, different technology missions we created. And the second major element of the agriculture R&D development has been the open access of the public research products. It's the further use and the commercialization. So policy paved the way for the public-private partnership, transfer of the technology, and diversification of input markets, particularly the seeds and the fertilizer. Simultaneously, the coordinated research programs were also started by the ICR with the funds earmarked for this particular activity in the form of ECRIPS. International foundations like Rockefeller Foundations also played a major role in the past in developing and utilizing the coordinated research programs. So this policy of institutional linkage was extended to the private R&D organizations, and we made the partners in the process of the commercialization, upscaling, and demonstration of technology. With the growth in agriculture R&D system, it was realized that the public funding exclusively not to be for the public institutions, and the private sector could be a partner in addressing the national R&D, the priorities national R&D needs. So with this idea, the funding for private institutions emerged. So in this view, the public funds were made available to the private institutions either through the sponsored research projects or through the competitive funding. So nearly 10% of the ICR budget is spent on the demonstration of the technology and the skill development in partnership with the private and the civil society organizations. This initiative put India into a few of the countries having the public-private partnership in agricultural R&D. So as the system expanded, agriculture R&D managers paid their attention for the sharing of information and resources among different disciplines, programs, and institutions to maintain the productivity of the systems. So management innovations for the better research planning, regulation of R&D, and linkage with farmers and other users were also initiated, mainly for the two regions. One, the Indian agricultural R&D system being largest in the globe, necessitated innovation in the management, better targeting research for improving its efficiency and fostering the partnership. So the important innovation include the adoption of the eco-regional learning, objectivity, and the transparency in the resource allocation, and the program monitoring and the competitive funding. So the performance assessment both for the organization and the scientific personnel were started with the more objectivity and the transparency. So the second, the policy reforms was the regulation of biotechnology research and the commercialization of the transgenic product. The main idea was that the risk assessment of the product must be scientifically sound and the product likely to generate high economic benefits be commercialized. So that was the idea. So now a government is considering the unification of the regulatory system under one agency, as well as incorporating the social concerns which are being raised, particularly for the transgenic products, transgenic crops. So regarding the intellectual property rights in the country, international agreement, patent amendment, product process, law for protection of variety, there has been an increasing awareness and the development. Now the public-private sectors are seeking the protection of their intellectuals property rights. So the final success of these mechanisms will depend on their the credibility and effectiveness. How far these regulations shall attract the investment in agriculture, R&D, diversify the private research portfolio to breeding of open pollinated crops, influence competitiveness in input and technology markets will be known in years to come. As we all know, the private sector are mainly in the hybrid, the cross, not in the open pollinated crops. They are in the other crops where the profit is high. But with this, we believe that their entry would also be in the open pollinated crops. So instances of spilling of the international technology in the area of plant growth regulators, machinery, and chemicals also is taking the place. So sustained public funding has been instrumental in establishing the agriculture research infrastructure in the country. If we talk about the agriculture R&D organizations, we categorize our R&D system mainly into three categories: ICR and its network institutions, research institutions, state agricultural universities, and the agriculture extension system. So if we talk about the ICR research institutions, we have 112 research institutions of different types in the country. We have a national institutions dealing with national priorities. We have a central institutions. We have a type of the national research centers, national bureaus, particularly dealing the resources of animal, soil, biodiversity resources. We have a directorate, and we have a agriculture technology application research institutions in number 22. So we have 112 research institutions under the domain of ICAR. We have a 63 state agriculture universities. We also have 3 central agriculture universities, and we have a agriculture faculty in central universities. So to make the council an effective system to promote, guide, and the coordinated agriculture research, the government of India appointed various review teams. So first it was established in 1954, second was in 1959, and third was one in 1963, to look into the problems being faced by the system and suggest the suitable changes needed. So keeping the suggestion in view of the committees, ICR was restructured in 1965 as the supreme agency, a central agency for the coordinating, directing, and promoting agricultural research and education in the country. The council structure was further modified in 1973, and the Department of Agriculture, Research and Education, as we call in brief DARE, was established and attached to the government of India for the main The main idea was to have a link with the government for the collaboration and taking the guidance. Simultaneously, the Agricultural Scientist Recruitment Board, ASRB, was also established in 1973 to recruit scientific positions and conduct assessment of their scientific personnel for the promotion. The national research systems were established. It were created to direct the concentrated efforts towards resolving the national problems concerning a scientific specific crop or the commodity in a mission mode. Discipline, multidisciplinary groups led by the eminent scientists, where the central research institutes were not able to give the special attention. The NRCs were created. So the All India Coordinated Research products were also created. This model system is an interdisciplinary and interinstitutional in the collaboration. It enables most effective utilization of the limited resources, both men and material, to solve the national problem, regional problem, local problem, with the idea of predetermined objective, the priorities, and the strategies. The eclipse to cover disciplines and the commodities, soils, the crop, livestock, the fisheries, engineering. Presently, we are running the 57 such eclipse in the country. So network projects were also initiated where the eclipse was not present. So the idea was for the development, the testing and identification of the technologies through multi-location trials in those areas issues where the eclipse was not present. So such network projects at present number is 25. So the center of excellence were also created to ensure the focus on the frontier areas of research. The scheme of Professor of Eminence and National Fellows has been started for the developing strong research and education in the area of basic research. The idea was to strengthen the basic research. The National Agriculture Research projects were also started in 1979 with the help of the World Bank to strengthen permanently the capability of the state agriculture universities to conduct location-specific and production-oriented research on the basis of identification of agroclimatic zones, which they are in number 127 in this country. So two more central agriculture universities have created for imparting the post-graduation education. One at Ranchi and the another one at the Assam, on the line of the IERI Indian Agriculture Research Institute. On that pattern, this so deemed university model in the ICR is considered to be more successful. The reason is that it delivers the quality education because of the low student faculty ratio. As we all know, the four such institutions, the Indian Agriculture Research Institute, Indian Veterinary Research Institute, National Dairy Research Institutes, and the Central Fisheries Education Research Institute, such Central Institute of Fishery Education, the CFA. So such institutions are praised because of their providing quality education. They are the fact attracts more institutions to develop the system on such lines. The ICR institutions are working well and has a linkage with both national and international organizations, systems. However, the NRC is there is the problem with the NRC is weakening because of the less number of the critical scientific manpower, which is increasing the overhead cost, reducing the efficiency, and it needs the immediate attention for the correction. So in the process of the organizational development, the funding of SAU comes from their respective states, as you all know. But these are the autonomous institutions. They are mandated basically for the agricultural education and state-specific research in partnership with ICR institutions. So in a bid to create the new universities from the existing one, the ICR resources are getting fragmented, leading to shrinking of the faculty number and the loss of the faculty character. In the process of creating number of agriculture universities, these are the problems have been realized, and the idea is to stop such kind of the creation. This must be reversed if we want to check the quality and the faculty strength of SAU that should be restored to the level of 1980, as we were having about 25,000 agricultural scientists in this country. But the number has been reduced very drastically, particularly in the state agriculture universities. The ICR SAU model has been quite successful, and they have been replicated in the Asian and African countries. And the main reason for the success has been the central agency being ICR guide, coordinate, and provide fund and institutional linkage. ICR believes in taking the innovative programs and reforms, providing the funding support, and ensures greater the compliance of these reforms. The other government departments are expanding their network on the pattern of ICR. Basically, the DST, DBT largely in supporting the research through the extramural funding. Only the CSIR is organized in a research institute mode with greater autonomy to their institutions. The agriculture extension system has evolved over time on the three broad lines. The main extension system that is lies with the State Department, grappling to gain the independent institutional identity, started with the multi-purpose development departments and subsequently evolved into a specialized extension system, emphasizing direct contact with the farmers under the training and budget system. But this model collapsed during the late 80s. Its model became ineffective with the shrinking manpower, and therefore it was shifted with the agriculture technology management agencies and has a linkage with the Krishi Vigyan Kendra and the state agriculture university. The second system was the institutions of the capacity building of our extension personnel, both at the central and state level. These institutions are expected to initiate and initialize the extension reforms. Funding to these institutions come from their respective states. The third system, which is mainly run with the ICR, the funding which is received from the central government, is the network of the Krishi Vigyan Kendra, the Farm Science Center, presently the 725 in number. In almost all the districts, we have the Krishi Vigyan Kendra. In some districts, we have more than one also. They are intended for science and technology led agricultural growth for enhancing the productivity, the profitability, and sustainability of the agriculture. They basically demonstrate the new technology and impart training to the farmers. They have a strong linkage with the ICR and SAUs for the technical support and provide the successful and they are quite successful. They have proved that they are quite successful with some limitations. The ICR SAU system has its own activity of on-farm assessment and refinement of their technologies through Etika Agriculture Technology Information Center at their main gate. So the private R&D has emerged, both the profit and non-profit units. Since the population of the tractors, fertilizer, and pesticides, the non-profit units are mainly active in the natural resource management and the promotion of location-specific technologies. The private R&D profits have increased over the time with expanding markets, basically in the area of inputs and commercialization of Indian agriculture. The availability of the scientific manpower, infrastructure, access to public research products paved the way for the emergence of the private R&D system in this country. The private investment is mainly for the in-house research. Input companies mainly provide input mainly in the area of breeding, pesticide, food processing, animal health, farm machinery. So private R&D organizations are mainly of the multinational companies, mostly active in seeds, large national companies in all the field of agriculture R&D, and small national companies working at the regional level. Small area coverage. Input markets are quite competitive now, but in the import of technology and IPR, large companies are dominating. The disproportionate increase in prices owing to the monopolization needs the interventions by the government. So the Indian agriculture R&D system has responded well to the national challenges, be it the increasing efficiency, equity, the sustainability, the trade aspect, price, but the complexity of the research and regulatory issues have also need to be addressed. Multi-developmental challenges. At one time, we need to increase the production, but another time we need to have the inclusive growth, sustainability of the resources to be maintained, especially of the soil and water, nutritive aspects, and the quality improvement. So these conflicting challenges require more research funding, more research resources, and their targeting. So the Indian system required to regulate R&D in a compliance with the international commitments also and scientific principles, seek participation of the stakeholders, and incorporate the social concerns in the decision making. So all these challenges, all the tasks needs more resources to put required mechanism in place and make balance of the concern. These goals are not possible to achieve in a short period of time. This requires the long research policy support. So learn from the national and international experiences and promote science for the society. So one major problem of the regulatory mechanism is the presently this is the outside system of the agriculture R&D and no adequate capacity to handle the multiplicity of the issues. National efforts and the capacity building required with the government departments and fostering close interactions is needed. So international agriculture research systems, mainly the consultative group of international agriculture research like the International Food Policy Research Institute, International Wheat Research, International water institution, international livestock. Such a CGIAR system has been the main ally of the national system, and the significant changes have taken place, particularly in the organization, funding, and research trust. More research is done under the project funding mode, while the funding have drastically reduced. Now the greater emphasis on the location-specific action research in multidisciplinary mode. This is a welcome step to enhance the impact, but the strategic research focus should also be maintained for the long-term issues to be addressed. So this implies that the the technology spillover and the exchange of knowledge will be a concern if not given due priority. So the responsibility of fostering linkage with the national culture research system with the CGIAR and multilateral donor, and these they are upscaling. The NARS has to shoulder the increasing responsibility with providing the leadership and facilitate the technology spilling. Participation of the private R&D in private sector in R&D for inputs, agro-processing, farm machinery is expected to increase, and the public system should initiate measures to foster the partnership. So the IPR regime will be an important instrument to facilitate the research partnership. So the strengthening of the SAU is a major challenge, especially when the ICR has no or the limited administrative control over them. The concern of the mobilizing operating funds, modernizing the infrastructure, and the most importantly, maintaining the critical faculty strength in the various disciplines. So ICR can provide necessary seed fund for the leadership, but the efforts made by the SAU in mobilizing support from the state government will have the larger role, are the most important aspect, as they employ two sorts of the scientific manpower from their own resources. ICR funding is less. So this is required to restore the research education linkage and to promote integration of the agriculture and the technology at the regional level and facilitate their upload to the farmers. Research extension linkage and the revival of the public extension system continue to be a major challenge, improving the overall effectiveness of the agriculture R&D. The lack of effectiveness, the lack of funding, the manpower, and the skills are the major weakness of the public extension system. Development of Atma has given the institutional identity to the extension and has promoted the decentralized extension in a bottom-up manner, but the need to nurture the linkage with the State Department and the KBK. KBK have to play a larger role in skilling development, the technology demonstration to address the location-specific problems and dissemination of information to the farmers. So the private input companies are undertaking the promotion of their products, input embedded with the improved technology, but are lacking in larger social objectives to promote the best product. The public extension system be a key to serve the small and marginal farmers, as these groups will not be able to provide the so thus a pluralistic system of the farm extension and advisory services should evolve in years to come. So the concept of agriculture innovation system is gaining popularity, which recognizes the role of knowledge creators, the traditional knowledge and interaction among the actors for the sharing knowledge and promoting innovation. The concept of agriculture innovation system is gaining popularity, which recognizes the role of knowledge creator. So in this context, extension system should have to play a larger role in developing linkage with the various stakeholders to help the farmers. So the necessary condition for this is to create an enabling environment for interaction and knowledge sharing among the multi-stakeholders to create the capacity to innovate products, process, and institutions. So the necessary development of these conditions will require the huge public investment, especially for the HRD at all levels, farmers, strengthening, and the others. So, with the organizational development, now we will be dealing with the technology in the agriculture. In the present world, due to advent of the technology, there has been a huge change in the agriculture operation at the farm, and it has played a big role in the developing agriculture. Traditionally, the farmers were doing the agriculture operation, and it was a time consuming. Nowadays, farmers use machine tools, techniques for farming that offers best outputs and profit. These tools are not only profitable but are also safe, eco-friendly. In India, we see that the technology has brought an awareness among the farmers. Hence, their use has increased. Today, it is possible to grow the crops even in the desert area using the agriculture biotechnology and grow engineered plants in the drought condition and against pest. So the concept that development or the creation of any new variety, breeds, machine, practice, improvement in existing, which are capable of giving the better results over the existing one, is described as the technology. Broadly, it is described as technology. With the advances in agriculture technology, farmers could produce more output, more yields, using the better inputs. So advancements in agriculture technology are an important contributor in sustaining our agriculture production system and making to it's all. With this, we are improving the health aspect, well-being of the millions of people. So if you see the benefits, the technology is called a panacea for the rural India, capable in improving the quality of life, especially of the poor and disadvantaged group. So inputs of the technological advancement in agriculture, like irrigation, water management, health, communication, biotechnology, GIS holds the tremendous promise to the individuals' lives and enable the rural India to progress. If the technology is meant for the rural area, should be used to fulfill the basic needs and improve the quality of life. Some of the cutting edge areas, space, biotechnology, ICT, can have a great relevance, and the technology is seen as a means to empower and to bridge the distance between the hope and the opportunity. So ICR units in the past few years have developed a number of technologies, the yielding varieties, stress-tolerant varieties, hybrids for the different agroclimatic zones. Besides 130 varieties of 54 horticultural crops were developed in fisheries, breeding and fish production technologies. Where the technologies are disseminated to the farmers through a network of the Krishi Vigyan Kendra, duly tested, passed through the line departments, state line departments for the larger demonstration. We use the different kinds of the technology. We use machine, we use the transportation related technology, cooling related technology, genetically produced plants, development of the animal feed, breeding of animal resistance to diseases, irrigation of the plants, the micro irrigation, drip irrigation, sprinkler irrigation, plowing and leveling related technologies, harvesting and threshing related technologies, grading and processing related technology, like the technologies we have developed, we are developing. So the research in the form of the technology that provides both tangible and intangible benefits. Tangible benefits, we know the idea of the intangible benefits could be the better health, reduce the infant mortality rate, national defense, to quality related traits, flavor, aroma, size, color, so on. The unintended negative effects have also emerged with the development of technology. The burning example is the climate change, the degradation of the soil and water resources, degradation of agrobiodiversity is the another burning example. There are multiple research objectives before developing any technology. We have the economic efficiency are the most, and then simultaneously we also have the objective of equity, income distribution, and the security objectives are different. We keep in mind different the producer group, different size group, different tenurial system, ownership, different consumers, their nutritional implication, the income risk, and the self-sufficiency, and the sustainability of the resources. We also keep in mind the environmental safety, the conserving the agrobiodiversity, trade-off of the above objectives in mind. And so we do different types of research. We related to the crop improvement. We develop variety. We develop hybrids. We have developed the BT hybrids. The yield and the quality improvement, or the yield and the quality improvement. The resource management related research we do for related to soil, water, land degradation, biotechnology. In the other frontier research, we develop the variety using the tissue culture, genomics. The protection related research, we take the indicated pest management of the crop, BT varieties. We also undertake the socioeconomic and the policy related research and their impact on the farmers, society. So so what is the impact? Impact is broadly defined as a making lasting impression or effect. So the idea is impact would be one which lasts for a longer period of time. The changes, the development which has taken place, it should be long lasting. It has a effect at the longer period of time, making the lasting influence to the national development objective is also. So impact is defined. It could be a positive impact. It could be a negative impact. It could be a primary impact. It could be a secondary impact. It could be a direct impact. It could be an indirect impact. It could be an unintended impact at the longer term, so that it can be attributed to the outputs made by the agricultural R&D. So, so why we take the impact assessment? Because of the scarcity is a global phenomena, and India is no more left than this. The increasing societal challenges society likes to know what has been the contribution of their research funding. So they need the exhibit the accountability of the system. Donors seek the evidence of the impact of their past funding which they provided. It helps in decision making the process and allocating the resources efficiently. So in the other word, it helps in setting the research priority, and research environment is changing about at the global level and the sectoral level. So all these regions is make the idea for the impact assessment. Regarding the since agriculture research and economic activity, so in the Indian condition, we invest about 200 billion rupees for the agricultural R&D, and if we see in terms of the share of agricultural GDP, what we produce, it is about 0.0616% of that. So the ICR also spends more than 7,000 crore, and it per institution, if you see, it's about 65 crore. So the basic economic principles always keep in mind before the analysis. How much resources should we spend? How should it be spent? Who should spend it? Who should pay for it? What is the role of private sector? How can the resources be used more efficiently? All these are the basic economic questions is posed before the idea for making the economic impact or the impact of any technology impact of any investment. So the general purpose of the impact assessment was to know what has produced the desired effect, whether they were needed. Most impact assessment were made to determine the adoption rate. The early impact assessment was mainly confined to the impact assessment related to the adoption of the technology and economic benefits of its investment. They show the credibility of R&D institutions and ensure the new findings. However, nowadays it is made for searching the unexpected effects, feedback for the researcher and the research institutions, identifying the defects and the diffusion of development, derive the strategic and programming lessons to provide information for the management decisions and to prioritize the investment. So how to make the impact? The earlier how the impact assessment were made, the anecdotal evidences, the evidences from the different places in a limited manner, and then the idea was the micro level impact, numerous and scattered micro level impact assessment, the case studies, but that also not give the clear picture for the policy maker. So the idea was for the micro level, what has been the productivity change, for example, what has been the area and the production increase for the adoption of a variety, what has been the employment increase, what has been the institutional security, what has been to the institutional security, what it has contributed to the export basket, all those. Generally, the impact assessment is categorized into the mainly three categories: the econometric approach, estimating the marginal productivity; the programming approach, the optimum technology research, identifying one or more optimal technologies; and the economic approach mainly aims at measuring the aggregate social benefits of a particular research project. So all these three methods are in widespread use, but this A third method is most popular because of its simplicity and the less data need. So the IA can also be categorized into the ex ante and exposed. Exposed studies are taken after the technology is being used, and the ex ante studies for the technology not yet adopted. But using this ex ante approach, one can give some idea about the what will be the future of this technology. In both the cases, data required to measure the impact can be directly observed, and the others to be estimated indirectly from the other evidence. Choosing and using the data is perhaps the most single important skill required in the impact assessment. X assessment uses the actual data and are the more reliable than that of the ex ante. Difference in both methods based on the judgment of the researchers and interpretation of the data. So we take the impact at the farm level, individual household. We take into account the category of household. We take into account, if we take at the regional level, we target districts, the agro-eco region. We target the states. If we take at the national level, we see the idea about the agriculture, increased agriculture production, prices, and the increased export, decline in the poverty and sustainability of this. We also take at the global level. So if we take the indicator at the farm level, so efficiency will be the one. So under that we can have the sub indicator, the profit. We can have the cost reduction, cost saving. At the household food and nutrition security, nutritional security could be the other. The income augmentation and poverty reduction could be the another indicator. Overcoming risk and uncertainty could be another indicator. Gender related and the resource conservation. So if we take the impact at the regional level, and then the increase in the production, food security, employment issues, equity issues, the poverty, the trade related aspect could be the one. If we take the impact at the national level, then increase in production, the decline in prices, the trade, the promotion, the import substitution, and what has been the spillover, all those and then global level, if we talk about, so what has been the prices, what has been the cross-border diseases, what has been the poverty relation, and the global warming, all those. So approaches, what has we follow macro approach, the programming approach, economic surplus approach, sustainable livelihood, the framework, socioeconomic and policy research, the framework, different framework we use for the impact assessment. Briefly, the economic benefits of a research. So we undertake a research. So there will be a research lag. There will be the expenditure. After that, there will be a research lag. After that, the technology is developed. Then it is adopted. It reaches to a ceiling. After that, it declines. So this is all talked about the adoption, the process. It requires time. It requires the cost. Then this is the model which we. So with the adoption of the technology, supply increases, the price decrease. So we measure with the area AB, the CD which is given with this. So the agricultural technology which we evaluated at this institute, the crop science related technologies, horticulture science related technologies, animal science related technologies, fishery science, agricultural engineering, and natural resource management. A total of 29 agricultural technologies we evaluated at this institute. And what we could found that the rice variety of the Pusa Basmati is providing about the 19,000 crore, 14,000 crore per annum. Then the wheat variety has provided the about 12,000 crore, and then the sugarcane variety about 10,000 crore, and then the different technologies are providing different level of returns. So what we need, if we summarize for the development of agriculture R&D and development of technologies, the most requirement has been the committed funding by the government, and the public system should take a leadership role and responsibility of the strategic research and manpower planning. The public system should be sustained with the capacity for the institutional learning and adaptation of funding management reforms is needed. All these needs allocation of a significant proportion of resources to sustain reforms. Sustainability of the public funding is a must for the capacity building and should enhance the innovativeness and the productivity of research. So the role of the private sector will be growing in the years to come in agriculture, but its will depend on the facilitating regulation, the trained manpower, and the transparent sharing of resources and donors should bring the international experience to accelerate the diversification process and facilitate the institutional reforms. Research system should work with extension system with the government departments for the capacity building of extension the personnel and the farmers, and thereby sustain the flow of technology to farmers. So thank you very much with this for your patient hearing. I invite any questions if it is. Thank you very much.
You can unshare your screen, Pandeyji, so that you can see others.
Stop sharing.
Yeah, you can stop your stop sharing your screen.
Okay.
Yes. Any questions? There is, I don't think there are questions. Only one comment is there that nowadays plenty of programs are formulated.
Hello, madam. Can I ask? Yeah.
Yes, Dr. Wang.
Yeah. Hello. Good evening, sir. Thank you, sir, for your thought-provoking lecture about the policy and all other kind of the thing that is being implemented under the agriculture sector. Sir, if you look to recently published, that is a budget for the year 2022 and 23. So if you observe that the government itself, they have mentioned that on the one side, that is the promotion of the drone, mainly like, let's say, the crop monitoring, then digitization of the, let's say, land records. And thirdly, which is more important, that is the spraying of insecticide and the pesticide. And on the other side, they are suggesting, or they are making some policy like that is the promotion of, let's say, natural farming or zero budget farming or the organic farming. So if you see these two scenarios, how it will be going to be work from the policy perspective, sir, which seems to be for me that is the opposite or contradictory.
Any other question?
And it will be better for everyone, you write your questions in QA, because that will save some time also. All
Yes.
attendees also, like if you have any questions, you can write in the chat box or QA.
For me, madam, in Q&A session, I am not able to write. Only I can see the someone's Q&A section, that is the answer. I don't know why it is so.
Yeah. Pandeyji, there is no more question. You can answer this.
It was from the Professor Harshvardhan Wag. Dr. Saab, thank you
Yes,
very much for good the question. The idea of use of drone.
आपका कैमरा थोड़ा सा नीचे है, आपका फेस पूरा नहीं आ रहा है. हाँ.
Now the idea of natural farming, the promotion of natural farming. Using this lecture, you can better identify the indicators how you can estimate the benefits of using the drone or the adoption of natural farming. Natural farming is in a very nascent stage. We are aware of it. And we have done some exercise, but because of it's a very preliminary results, we are not sharing that to the audience. Drone is also a very good idea, and when its use will be widespread, people will be starting looking there. Its benefit in terms of economic benefits, in terms of its social benefits, in terms of its other benefits.
Okay. So thank you, Pandeyji, for very informative lecture. Now from the side of participants, I'll request Anita to propose vote of thanks.
Good evening, one and all. I'm Anita. Yes, I'm a research scientist from the Institute of Environmental Management and Policy Research Institute, Bangalore, and I take this opportunity to thank our beloved scientist, Dr. Sant Kumar Pandeyji sir, who have elaborately explained what is agricultural R&D and how it has originated, and how the things are taken up, and what was in the initial days, and how we have progressed. Everything he detailedly explained, and it was very informative. And also he has gone through given the importance of the impact assessment and using the indicators for different levels. All those things, I think we should be considered in our future projects or anything we conduct in our domain. So I thank on the behalf of the organizers and also panelists who are and also participants who are attending the training session. I thank Dr. Sant Kumar Pandeyji for your wonderful session. Thank you so much. And I also thank organizers giving us the opportunity to attend this training. Thank you, ma'am.
Thank you, dear participants and the organizers, for giving me the opportunity.
Thank you.
Thank you.
Thank you very much for the wonderful lecture and agreeing to deliver the lecture. Like openly, you have given options for any day, any time. So thank you so much for the cooperation. Thank you very much, Pandeyji. Thank you. So thanks a lot. So now our esteemed participants, there is a good thing for you, good news for you is that tomorrow we are not having that 11:30 session of group formation because all the things are completed today only. During that time, you can discuss among your groups. Okay, now Mr. Dilip has taken pain to create groups for you. So all 6 groups, links have been sent on your WhatsApp. In that, by clicking there, you can be joining your respective groups. And list also has been posted on the group. You can see if you do not know which group you belong to. So these things you can complete, because now when we are having one by one, normally just to keep you a little relaxed, every day we are trying to have one lecture on techniques and one lecture on applications or policy issues, research, especially like work this institute has been doing. We have been including almost every work of this institute in these lectures. So every day you will find such kind of combination, because if all the techniques are done in the beginning, then it will be very difficult to practice and do the things. So you can have some practice on your own and try to grasp the technique. And somebody is saying question answers access is not there. So how that is, I don't know why, like we had tried to give, can comment all questions. We had tried to give this, but I will check tomorrow onwards. You will get access to question and answer also. There is no this thing, whatever is there in our hands within the technology, we will try to provide that. So no issue
Madam,
regarding
yesterday
this.
also I was unable to give answer, madam. The day before yesterday.
Able to answer or unable
means,
to ask question?
Ask question, madam. Means
I
the
will
talk option was not there.
request my colleague Mr. Dilip and Mr. Chauhan to check this, like check the settings and enable the question answers for everyone, not only for the panelist, basically. So, and I am getting some request for including you in the panelist and or attendees. So this is something which is difficult for us, but we will try to see in coming days what options we have, because it is not so easy to have this kind of setting also. So, but we will see, in case we can do something about it, we will definitely do. So you do not worry on that. So if there is no question, Dilip, can you check whether this setting can be allowed? Question answer settings.
Wait, ma'am.
Dr. Pandey may leave if you want.
Ma'am, after
no problem.
training, we can check.
After this meeting is over, we will definitely check and it will be available to all. So tomorrow we will be meeting at 2:30 again. As usual, this will open at 2, and like you can take your time in joining, and we will meet at 2:30. In forenoon, you can have interaction among yourself. You can make your own group. Somebody from you can make some link also if you want to have one-to-one interaction using Zoom account or something. So that you can do, because in a big group, all of you will not be able to have your own discussions. So for that, you have to have your internal discussion. You try to understand who is expert in what, so that later on you can make your presentations at the end of the training. So that's all from my side. Dr. Subhash, if you would like to add something.
You have said all the things right way, madam. Thank you. Only the thing is that if any participant is facing any kind of problem in attending, or not able to hear, or something technical problem, or they want any specific lecture, so you tell in advance so that we have sufficient time to arrange or rectify the problem if you have. Our team is working on the things you are pointing out, like you are not able to write in question answer. That's what madam has said now. And anything what we possible in because this is a virtual mode, and this physical mode and virtual mode make a lot of difference. We should understand. So because
Also, it is a
depend
challenge for
completely,
us also.
it can depend completely on the technology, what is available and what is with us and with you. Sometimes your network is not internet not working. Sometimes our not working. It is slow and all. So this kind of things happen. Okay. Dr. Harshvardhan is there, sir?
Yes, sir.
Professor, is there? Sir, you tell, you asked one question, Dr. Santkumar has replied to you already. But anyway, you tell your view on that question, what you have asked. What is your view? What government should do?
Yeah, actually, I was expecting what is the opinion of this, because they have very experience and they are very rich experience from the policy perspective. As I was looking to that time budget, because they have mentioned what is the Kisan drone. They have namely three use, like let's say the crop monitoring. Then second one, that is the digitization of land. Okay, that is also important. And third one, they have mentioned that is the spraying of insecticide and pesticide. Okay, because they have listed these are the